In this video, we will discuss how to value a plain vanilla interest rate swap. Interest rate swaps are quoted as shown over here, where we are swapping out a fixed rate for the floating rate SOFR, which is the modern replacement for LIBOR, the London Interbank Offer Rate. And if you have a one-year swap, you would be currently swapping out a fixed rate of 5.33%, a 5-year swap 4.48%, and a 30-year swap 4.2% for the floating rate SOFR. This shows the current swap rate, the swap rate a few days ago, swap rate a month ago, and the swap rate a year ago. As the Federal Reserve has recently increased interest rates, swap interest rates have gone up. The market anticipates that interest rates will go back down, so rates for 30 years are below rates for the current time period. We will study these swaps by using a problem similar to a problem out of the Excellent Text Options, Futures, and Derivatives by John C. Hall, which reads as follows. A financial institution has an interest rate swap with company X. Under the terms of the swap, it receives 10% per annum and pays 6-month LIBOR on a principal of $10 million for 5 years, initially a 5-year swap. Payments are made every 6 months. Suppose that company X defaults on the 6th payment date, end of year 3, so there are 2 more years of payments, or 4 more payments remaining, plus the one that was just defaulted on. So we will have a total of 4 more payments, or 2 more years remaining, plus the one that was just defaulted on. That will be 1, 2, 3, 4, and I'll show down here the final $10 million principal being exchanged, when the interest rate with semi-annual compounding is 8%. So that is now the market rate. 6 months ago, LIBOR was 9% per annum halfway through year 3, which would determine the LIBOR payment when the default takes place, right here. So we will value this in 2 different ways, difference in bond values, and also a series of forward rate agreements. The fixed payment is shown here, and that's never going to change. So the fixed payment is going to be 10% times the principal divided by 2, and then we will convert it from millions to dollars, so we multiply it by the 1 million, and we get each of the fixed payments is going to be $500,000, and then we're showing the final $10 million principal, I guess, exchanged back and forth and canceling out here. On the floating rate side, well, the floating rate that was just defaulted on would be the LIBOR 6 months ago, or 9%, times the principal divided by 2 times a million, or 450,000. So the payment defaulted on is the difference between these two, are $50,000. It's being defaulted on immediately, so its present value is $50,000. The next payment on the floating rate side will be based on the current market rate of 8%, so it's going to be that 8% here times the principal of $10 million divided by 2, or $400,000. And all of the future defaulted on LIBOR payments, we're going to assume, are also the $400,000. So right now, $50,000 was defaulted on, and they're effectively defaulting on $100,000 for each of the next 4 payments, one made in 6 months, a year, 1.5 years, and 2 years. To figure out the value of the swap being defaulted on, then we need to figure out the present value of all of these defaults. So the one just happened is $50,000. The one to be happening in 6 months will be $100,000 divided by 1 plus the 6-month interest rate. So the current market rate is 8% divided by 2, 6-month rate, and that occurs in 1 6-month time period here and has a valuation of $96,000. The next one, the next default present value of, occurs in 1 year, or 2 6-month time periods. So it's going to be $100,000 divided by 1 plus the 6-month rate, which is 8 divided by 2, or 4, 2 6-month time periods, 2. And the next $100,000 defaulted on is 100 divided by 1.04 again, to now 3 6-month time periods, or a year and a half, gives us 88,899. And the final one occurs in 2 years, or 4 6-month time periods. So we get $100,000 divided by 1.04 to the fourth, or $85,000. If we sum up all of these, we get the value of the swap being defaulted on is $412,008, or $989.52. So this is using a series of forwards. The other way to value the swap is a difference in bond values. So if we do a difference in bond values, first we will figure out the value of the fixed rate side and then the value of the floating rate side, and subtract one from the other. So the value of the fixed rate bond is just going to be the discounted sum of each of the payments. And what are the payments for the fixed rate bond? Well, we would look at it as a bunch of $500,000 followed by a $10 million payment. So the first payment being defaulted on is $500,000. The second payment being defaulted on is the $500,000 divided by 1 plus our interest rate, which is this divided by 2, or 4%, times B21 for 1 6-month time period, or 480. And the next one will be over 2 6-month time periods. So we have our principal, or our payment here of $500,000 divided by 1 plus 4% to B22, which is 2 6-month time periods. This will be the same to 3 6-month time periods, now to 4 6-month time periods, or 3 here, 4 here, 6-month time periods. And then the final payment will be the bullet payment here of $10 million. And that's going to be the $10 million over 1 plus, again, 4% to B25, or 4 6-month time periods, since that payment, the bullet payment, takes place at the same time period as the last fixed payment here. So we sum up all of these present values, and we get the present value of the fixture bond is $10,862,989.52. Now we can do the same thing for the floating rate bond, and you can do that a couple of different ways. Well, since the floating rate bond resets every time, then after the default, it's just going to be worth $10 million. So the value of the floating rate bond is going to be the value of the default of $450,000 here, plus the $10 million of the principal, or $10,450,000. You can also do that again by summing each of these payments. So the payment just defaulted on here was the $450,000, and then the present value of the next payment here of $400,000 is D21, this payment, divided by 1 plus 4% to the first power, and that gives you over here $384,615. Next payment doing the same way. Now it's going to be to B22, or 2 6-month time periods, and now to 3 6-month time periods, and then to 4 6-month time periods. And then final here, we have the $10 million par value of the bond divided by 1 plus 4%, again 8 divided by 2, now again to 4 6-month time periods. So summing all these up, we again get $10,450,000 is the present value of the floating rate bond, $10,862,000, $982.52 is the value of the fixed rate bond. You subtract one from the other, and you get the same number as we had over here, are $412,989.52. So either way, you get the same value of the swap at the time of default. I thank you for watching this video.